Applications are everywhere. That is because their users want to work, buy, and consume services in a cafe, train, airport, car, park, or even at a swimming pool. Internet has become single most important business channel and applications are core of this experience. But going mainstream means much increased pressure on quality and time to market. Many application development teams are struggling with this by implementing agile techniques with varying results. Let me tell you a story about similar transition which happened in the past so you can judge if we can learn from this past experience. In 908, cars were rare luxurious goods handcrafted towards individual customer tastes. Henry Ford has had a dream of a car for an everyman, Model T. By industrializing manufacturing process, Ford was able to go up from humble 11 cars per month to 9,000 a day and shorten manufacturing time from 12 hours to 1.5. At the same time, he managed to slash the price by 4. Around 1925, more than half of the cars around the world were Fords. As a side effect of this revolution, Ford could afford doubling salary at the production line and decreasing working hours at the same time. This was paramount to launching new social phenomenon, American middle class. How was all of this possible? Well, before 908, cars were handcrafted. Ford described production process and divided it into 84 areas assigned to different teams. What he created was measurable and highly predictable production process. Unfortunately for Model T, the method used required specification of the car to be well defined and fairly static. It is a known quote from Henry Ford's autobiography. Any customer can have a car painted at any color that he wants, so long as it is black. In today's words, one could say that the project was managed in a waterfall way with one big release and series of quick fixes. This eventually killed the project in 1927 as Ford T could not efficiently be modified to follow market trends. This gentleman, William Edwards Deming, is an inventor of a solution to Ford's problem. Deming was an American philosopher and Japanese national hero. He invented plan, do, check, act cycle, later named after himself. The idea behind is simple. Every production process can be optimized by planning change, implementing it, measuring delta in value versus previous situation, and comparing the result against expectations. The shorter the cycle is, the more improvement in quality and time to market can be achieved. Deming gained the national hero title when this principle got applied by Toyota, which then became world's quality leader for years to come. The method is not automotive business specific though. It can be applied to any manufacturing process in order to make it more value oriented or leaner. Making software is perceived as highly creative activity. Indeed, designing software is one, as any industrial design is, but implementation is an engineering discipline. If we consider an idea to be the input on which production process is executed to deliver value, then every release closes a Deming cycle. It is worth noticing that the value is only realized when the resulting feature is released and consumed by the end user. This is extremely important. No matter how agile development process is and how frequently the code is released to the pre-production environment, if the end user does only see quarterly release, then any development effort put in is merely a cost for 6 weeks on average. What is even worse is long feedback loop. For those 6 weeks, one does not even know if the effort put in made any sense for the end user whose expectations might be shifting meanwhile. The reality is that most companies declaring agile practices but missing automated delivery are still manufacturing software. So what does it take to make delivery truly continuous? Industry name for this is deployment pipeline, but I prefer to visualize it as conveyor belt, taking the release candidate from code commit via build, range of tests from a cheapest automated and quick to most expensive human driven and prolonged, And finally, the release. Let's spend a moment looking at critical capabilities of good deployment pipeline. First of all, it should not only automate build promotions, but also provide added visibility to the business on what is development currently working on and what is the stage. For release manager, on exact list and status of actions as well as test environment availability, and for operations, on contents of any release candidate and its test history. Ideally, the deployment pipeline is covering all environments because that is the only way to make releases less risky, more frequent, and actually shorten the feedback loop between the end user and the business. Deployment pipeline must be repeatable, and this can only be reliably achieved by automation. In order to make it valuable, it should be used by everybody in the organization for both code and environment configuration changes. There should be no other way to deploy. This way, deployment is subject to the same set of tests the code is going through. Used for every environment multiple hundred times a year, it is rock solid and believed in. To achieve this, same automation should be used no matter which environment and release scope is considered. This is extremely important to deploy production with the very same mechanism that was used for all tests before. Good deployment pipeline is self-documenting. Contrary to textual documentation, it always describes real actions and can be used for learning and audit purposes. Finally, by accumulating knowledge and taking over repeatable tasks, it should release human creativity to where it is needed most, to process improvement. Knowing this, let me show you how deployment pipeline can be implemented in BMC release lifecycle management. What you see here is the list of release plans for two possibly interdependent applications, each of them showing the historical releases plus the current one. And on the right hand side, you can see the breadcrumbs showing the actual release pipeline and the number of release candidates which made up to each of the steps. Let's focus on web application in its current release. Release plan is a view showing details of different stages. We start with a development stage, which roughly corresponds to first development smoke tests on each build. You can see continuous integration implemented here. Every build generated by Jenkins is automatically deployed to the right environment with the applicable workflow, with the result being logged under specific request. We also see two requests promoting two of the builds to the QA environment. Going down the sheet, we will see that first request, namely build 3.3, failed QA tests, while the other one, 3.5.5, is undergoing them right now. The same view can also be used to see the scope of the release by reviewing associated tickets. Those tickets can be sourced from any external ticketing system, including Jira, Rally, or even Remedy. We can also see multiple calendar views, graphically depicting the release deadlines, environment availability, and occupation. So let's get back into our plan and see what is happening in QA right now. Every request consists of mix of automatic and manual steps. You can see that in the assigned to column. If the step is manual, it is assigned to a particular group of users. Once these steps will execute, they will also document the timing and possible outcome of each of them. Right now, we can see that the application is deployed into the QA environment, and myself being a member of QA group, I am welcome to start my tests. Since every release candidate is recorded into the repository by the underlying deployment automation engine, you can easily use it to show the environment contents as well as the differences between particular release candidates. So for example, for web application, we can easily identify different components between release candidates 3.5.5 and 3.5.4. This way, RLM can provide visibility at various levels, from business through release management all the way down to the technical level. It can also self-document the process for different purposes, including audit. Big challenge around automating release process is its volatility. Not only big amount of possible environments and release scope combination complicates the process, but there are rollback options on top of that, making it even more complex and changing. This is why BMC release lifecycle management breaks up with the classical runbook approach to automate this process and instead defines it around answers to three questions. What should be deployed? How should it be done? And where does it go? The answer to the latter is basically a sequence of environments, logically identical, but implemented in different topologies and with different parameters. The answer to what question is a manifest of all possible application components, each of them triggering its own deployment process, where deployment process in turn is a sequence of actions. Now, because the components of the application are interrelated, once the manifest is instantiated for particular deployment, the deployment engine knows exactly not only which deployment processes should be executed, but also in which order. And particular actions within the deployment process are executed in context of specific middleware version and configuration for target environment. So for example, JPEG Store app is built of three components, one of which is a web application archive. This WAR file has its specific deployment process comprised of a sequence of actions. The product comes with the rich library of such actions, and you can easily extend it, for example, with application server configuration snippets. This way, BMC Release Lifecycle Management builds a process which is robust to changing environment and release scope, allowing you to use the same automation for all kinds of releases and build quality in every time it is used. The most unique result of applying lean manufacturing principle to software development is achieving both quality increase and time to market reduction at the same time. For example, by implementing BMC Release Lifecycle Management, Royal Bank of Canada was able to reduce time to deploy by 88%, which had significant impact on service window availability and thus time to market. But there's more than that. Frequent releases decrease associated stress levels, and push button deployment empowers the teams. All of this contributes to positive work environment and reduce staff churn. More visibility into environment configuration further reduces number of errors. And finally, the environments are easier to scale up and down as needed. What you see here is a car made by Toyota in its golden age. Being 50 years old, it is still a working car, but even more importantly, being a clone of Jeep, it surpassed original and has its die-hard fans even today. If you cannot afford an original, specialized companies can deliver replicas starting at $90,000. Toyota won these fans by listening to them and releasing right set of features at the right time with superior quality. Now, knowing all of that, the question is, do you want to build things your users love? If so, learn more on www.bmc.com/devops or contact your BMC account manager today.